Hope you're having a productive day. In this video, we will be going through another past paper question. This is going to be question number 4 of paper 2 for physics unit 1 in the 2015 exam. Let's get right into it. First thing we see is a diagram and a question surrounding the diagram. It says figure 5 shows a resultant vector A at an angle theta to the horizontal. There's a diagram right there. The question asks us to write expressions for AX and AY in terms of A and theta. And you can see that this is AY over here and this is AX here. Let us replicate this diagram first and then get into the question. Let us draw let's draw two axes. That's going to be the y-axis and this is going to be the x-axis. We have a vector, a resultant vector like this. So this vector is what the question calls A. And there's an angle between this vector and the horizontal, which the question calls theta. This is the y-axis and this is the x-axis. All right, this vector, for the sake of this question, has two components. It has a vertical component here and it has a horizontal component there. The question wants us to find the vertical component, which would be AY, and the horizontal component, which would be AX. How do we go about writing expressions for these two components? Well, we can use the trigonometric functions, sine and cosine specifically. Now, in trigonometry, the side that is facing the angle is the opposite side. The hypotenuse is the longest side of the right angle triangle, and the side that encloses the angle that is not the hypotenuse is the adjacent side. So the adjacent side basically encloses the angle alongside another side, which is normally the hypotenuse, right? We want to find the opposite side. We need to find a trigonometric function that incorporates the opposite and the hypotenuse, since we have the hypotenuse and we're trying to find the opposite. Which trigonometric function is that? Well, it just so happens that sine is that function. So sine of the angle theta is equivalent to the opposite side. So it's a side opposite this angle here, which is going to be this side here. Now this side is just exactly the same length as AY. So the opposite is basically AY. So sine is going to be the opposite, which is AY, over the hypotenuse. So the hypotenuse is A. All we need to do now is get AY by itself. In order to do that, we multiply this side by A to get rid of it on this side. And then we multiply this side by A since we multiplied the other side by A. We simply get AY is equal to A times sine theta. And that's basically the expression. Well, technically this is an equation. An expression would probably just be A sine theta. But if you write AY is equal to A sine theta, you probably will not be penalized because the answer is there. But it depends on how harshly the examiners want to act. To be safe, you could probably just write AY is represented by A sine theta. Maybe you won't get penalized for this because this is not necessarily an equation. Right? The question also asks us to write the expression for AX in terms of A and theta. Cosine. So cos theta is equivalent to the adjacent, which is AX, divided by the hypotenuse, which is A. Again, we multiply both sides by A. And we are left with the expression AX is A cos theta. So these two things here, this here and this here, are the two expressions for AY and AX. Let us move on to part B. A jogger runs 145 meters in a direction 20 degrees east of north and then 105 meters in a direction of 35 degrees south of east. Represent his resultant displacement using a suitable vector diagram. Let us get into doing that one right now. I'm going to do another grid or another graph. Some more axes are going to be drawn like that. And let's extend this one down as well like that. Yeah. Now the question says that a jogger runs 20 degrees east of north. What does that mean? Let us remember or familiarize ourselves with the coordinate system. So up is north, to the left is west, to the right is east, and then down is south. So if he goes 20 degrees east of north, he's going to go to the right of north by 20 degrees. What does that look like? Well, it's going to look something like this. This line represents the north axis, or it represents the y-axis, but up is north. So to the right of that would be this over here. As you can see, it's to the right. And I'm going to make the angle a little bit bigger because I want to have space to write. The angle between the north line there and the vector is said to be 20 degrees. So that is the first part of his journey. And this distance was stated to be 145 meters. He makes a detour, or he does something else in this. He doesn't continue to go in the same direction. Question then says he goes 105 meters in a direction 35 degrees south of east. So let us draw another line here. And this line represents the west-east axis, like this line does, right? Same thing. Let's say this side over here is east, right? The jogger went 35 degrees south of east, meaning he went below this line because it's south. So what does that look like? Well, it looks like this. He goes south like that, and he goes at an angle. The angle that he goes at is stated to be 35 degrees. So we have this vector here, and we have this vector here. Oh, by the way, the magnitude was stated to be 105 meters. So the resultant is basically the addition of the two vectors. How would we add these two vectors? Well, we've already added them using the tip to tail method, where we take the tip of one vector and add it to the tail of the other one. That's basically what we've done now. So all we have to do is just write the line that connects the two vectors, which is the line here. This line is indeed the resultant of the two vectors. And we can indicate that using this. So this line is basically the resultant of the two vectors. You could put stuff here on this axis, but you don't want to get confused. You just need to know that these are the two vectors. This is one, and then this is their resultant that we get by joining them, right? Good. Represent his resultant displacement using a suitable vector diagram. That is completed. We now move on to the other parts of the question. It says we should determine his northerly displacement from his starting point. How do we do that? To do that, I am going to draw a second diagram. The second diagram that I'm about to draw is going to have the same effect of this diagram, but it's going to be a little bit easier to use and understand. So I will replicate the axes like this, like that. I will redraw the first vector like this. Angle here is 20 degrees. And if this angle is 20 degrees, then this angle must be 70. Even though this angle looks bigger than this one, I only made it bigger because I wanted to write the 20 in the space. But in actuality, this line would be brought up about here. That's what 20 degrees would probably look like. But this diagram is not drawn to scale. So this is going to be 70 degrees, even though it is smaller. I just wanted space to write the 20. So this angle here is 70 degrees, and this helps us to solve the question a little bit easier. And then this vector is 145 meters. Now we're going to write the second vector. But instead of writing it at the tip of this vector, we're going to write it from the origin. So it's going to look something like this. And the angle here, the question stated, was 35 degrees. And the magnitude of the vector was indeed 105 meters. There you go. So this is basically the same as over here, but this shows the resultant more easily than this one does. This doesn't really show you the resultant, but this helps with calculations, as we will now see. Now the question wants us to find the northerly displacement of the jogger. How do we find that? We have to resolve both these vectors into their different components. To find the northerly displacement, we must take into consideration the vertical components of these two vectors, which is why I redrew the diagram, because getting the vertical components is going to be easier when the diagram looks like this. So as you can see over here, back over here, we wanted to find AY, which was the vertical component of A. How did we do that? We basically got A sine theta. It's the same thing over here. This is A, this is theta, and we want to find this AY. So to find that, it would be the same thing. So it would be sine of 70 times 145 meters gives us the vertical component of the first vector. And that vertical component is going to be equal to 136 meters. Now we are going to find the vertical component of this vector. The sine of 35 is going to give you the opposite, which is this side here, over the hypotenuse. So let's write it out. Sine 35 times 105 meters is equal to 60.2 meters. So to find the total displacement, we are going to add these two values together. But we can't just add them like that. We also have to take some things into consideration. Up is designated as positive, or in this case, north. Anything that goes in the north direction is designated as positive. Anything that goes in the south direction is designated as negative. Now, these two vectors, they are going in the same direction in terms of their horizontal components, but their vertical components are actually going in opposite directions. And you can see, because this vector is pointing somewhat upwards, while this one is pointing somewhat downwards. That means when we add them, this vector, or one of the vectors when we add them, is going to have to be negative, right? So because up is north and up is positive, we're going to say the vertical component of this vector is the positive, and then the vertical component of this vector, since it's going in the opposite direction, is the negative, or it's minus. So when we add these two vectors together, or when we add these two components together, we get 136 meters plus negative 60.2 meters. This is the same as 136 meters minus 60.2 meters. It's the same thing. And that answer is 75.8 meters. And that would be the northerly displacement from his starting point. The question then goes on to say, determine his resultant displacement from his starting point. This is a similar process, but now we also have to take into consideration the horizontal components. So the horizontal components, similar to over here, is going to be the hypotenuse times cos of the angle. So cos of 70 times 145 meters is equivalent to roughly 49 meters. And then for the second horizontal component, it's going to be cos 35 times 105 meters. It's going to be equivalent to 86 meters. So we are going to do the same thing. We're going to add these two components. Now, going back up to the picture, we can see clearly that the horizontal components are going in the same direction. As you can see, they're both going towards the right. So we do not have to set any of them as negative. Only if one of them was going in the opposite direction would we have to subtract. But because they're both going in the same direction when it comes to the horizontal components, we do not have to subtract anything. We can just add them. So these two numbers, this one up here and this one down here, are going to be added. So we're going to get 49 meters plus 86 meters is equal to 135 meters. Right then, we have the northerly displacement, which is this, and we have the, I guess you could say, easterly displacement, which is that. Now that we have these two, we have the components of the resultant. In order to find the resultant, we're going to have to add these two components together, or we're going to have to represent the two components together on a diagram. So let us draw yet another diagram. Now this horizontal component is 135 meters, so it is going to go along here. And that is 135 meters. The vertical component is going to be 75.8 meters, so that goes up here. Now we need to find, let me put in a number, 75.8. Now we need to find the resultant, which would basically be the line that connects the two. So it would be that. So we're trying to find the length of this resultant. How do we find the length of this resultant? Well, we are given the length of two sides, and this is a right-angled triangle. That means we can use Pythagoras' theorem. So Pythagoras' theorem says c squared is equivalent to a squared plus b squared. C in this scenario is the hypotenuse here. A can be this side and B can be that side. So c squared, or C, would basically be the square root of a squared plus b squared. So all we have to do to find C is find the square of A, which I can say is 135, and then the square of B, which is 75.8, and then add those two together, and then find the square root of all of that. When we have done that, we should get the answer of 154.8 meters. And that is the length of this side. So that is the resultant displacement's magnitude, or that is the magnitude for the resultant displacement. 154.8 meters. But we're not done yet, because we also have to find the angle. So how do we find this angle? Well, we could use the sine, the cosine. We could use sine or cosine. But if we use sine or cosine, then we're assuming that this 154.8 is actually correct, because sine and cosine both use the hypotenuse. So to find the angle, we would have to use this in the equation. If this number is not correct, if your calculations were off and you use this number, you will get a wrong answer for the angle, right? So you have to ensure that this number is correct. However, if you use these two numbers, this number can be incorrect and you still get the right angle if you use these two numbers. So what would you do if you wanted to use these two numbers and not the hypotenuse? You would have to use tan. Tan is equal to opposite over adjacent. So tan theta would be the opposite, which is 75.8 meters, over the adjacent, which is 135 meters. So tan theta is equivalent to, or is equal to, 0.56. And this doesn't have any units because the meters cancel. So we have tan theta is equal to 0.56. What would we do to get theta? Because theta is what we want. Well, if we have tan theta on this side, we can basically say theta is equal to tan inverse of 0.56. Run out of space. 0.56. So when you plug tan inverse 0.56 into your calculator, and to get the tan inverse function, you would press shift on your calculator, then press tan, and then it will give you tan inverse. So you get tan inverse of 0.56, and that gives us 29.2 degrees. Is actually, the angle here is actually 29 approximately degrees. So that basically tells you that the magnitude is 154.8 meters and it is 29 degrees north of east. You have to include the directions in your answer. You can't just say 29 degrees. You have to ensure that you put either north of east or some other identifier for where the 29 degrees is being taken from, right? In this situation, it is 29 degrees north of east, right? So that takes care of part B. Let us move on to part C. It is said that sprinters in a 100-meter race accelerate for the first 1/3 of the race. The following formula, T is equal to 2s divided by a raised to the x power, is proposed to compute the duration of the acceleration phase. By comparing the units, find the value of x. Now, this question is a little bit tricky because you don't really get too many numbers to work with. And as a matter of fact, the numbers that you get are kind of irrelevant, right? Because you basically have to solve this thing by observing the units, which is why it says by comparing units. So you can sit down and think for a while what you would do to find the answer, and then you can see if your method was indeed correct. Let's get into trying to solve this problem. First, rewrite the equation that they gave. T is equal to 2s over a raised to the x power. And it wants us to find the value of x. How are we going to find the value of x if you don't even have any numbers to work with? Well, you're just going to have to use the units, they say, and the answer will come if you follow the instructions. But it still takes a little bit of thinking. So the first thing we want to do is that we want to establish something. In order to get the value of x, if it's an exponent, we need something that looks like this. A variable raised to a known exponent, let's say 2, is equivalent to the same variable raised to the x component. Now, when we have something like this, we can easily find what x is by just saying 2 is equal to x. Because these two, the bases are the same, so the 2 and the x must also be the same if the equation is supposed to be true. So if we can get something looking like this, then we can solve for x. But how are we going to get something looking like this in the first place? That's what we're going to do now. The first thing we'll do is that we're going to take the x from here and put it over this side of the equation. But we can't just take x and drop it like that. We have to do a mathematical operation. The mathematical operation that we're going to do is we're going to find the x root of this side of the equation, which removes the x from here. And then when we find the x root of this side of the equation, we have to find the x root of this side of the equation. So basically, we're just going to do this. we're going to find the x root over here, and then we have to find the x root over here. So that basically gives us is equal to 2s over a. Now we come to some mathematics, some more mathematics. When we have the x root of t, it is the same as saying t raised to the 1 over x. How is that so? Well, it is a law of indices. Let's say we have a number, let's just say we have a variable x squared. We're going to take the square root of x squared. When we take the square root of x squared, we're just going to end up with x, since we squared it and then took the square root, so we're back where we started. So what you're saying is that x squared raised to some power, which we don't know, is equal to x. And this x is raised to the 1 because it's just x. Now, what you are doing is basically you're saying, what number can I put here to make it so that x squared raised to that number gives me 1? Well, you're basically saying that you're going to put a number here. When you put a number here, it multiplies this number according to one of the laws of indices, the bracket law, right? So what number would we multiply by 2 gives us 1? So 2 times a number gives us 1. What is that number? Well, we can divide this side by 2 and divide this side by 2. So the number is equal to a half. So this number here is basically a half. So we're basically saying that the square root is the same as a number raised to a half. Right? That's basically what we've just discovered. So with all of that mathematics, we can basically just say that t raised to the 1 over x is equivalent to, or is equal to, 2s over a. Now we can write some units for these quantities. T represents time. The unit of time is seconds. The symbol for seconds is s. So we'll just write s raised to the x. Now keep in mind, this s and this s are not the same. This s is a quantity and it represents distance. This s is a symbol and it represents seconds. There are two different s's, right? We will eventually get another s on this side, but you'll see how that one comes in later. Now let's continue with writing the units, because the question said units. We can drop the 2 because 2 doesn't have any units, it's just a constant. So we can work with s and a. S is a quantity that represents displacement. The unit for displacement is meters, so we end up with m in the numerator. Now we have a. A represents acceleration. The unit for acceleration is meters per second squared. Now you can see the m's cancel out, and we're left with s over x is equivalent to s to the minus 2, or 1 divided by s to the minus 2. There we go. Now this gives us another law of indices to work with. Basically, when we have 1 divided by a number that is raised to a negative exponent, it is the same as saying that number raised to that exponent. That's it. To prove that, you can basically say 1 divided by 2 raised to the minus 2, right? That's basically saying 1 divided by 1 divided by 2 squared. When we have a division and we have a fraction, we flip the fraction, we reciprocate it, so we get 1, and we change the division to multiplication. So we get 1 times 2 squared over 1. So basically, when you have a negative in the denominator, you can just bring the number from the denominator up and remove the negative power and change it to a positive power. So when we have 1 divided by s raised to the minus 2, we're actually saying just s squared. It's just a fancy way of writing s squared. So we continue and write the s with x to the minus 2. And now you can see we've ended up with that situation that I was talking about in the beginning. This situation here. We have two numbers that are of the same base, and then we have the variables in the indices. So we can basically say 1 over x is equal to 2. So what is x? Let us multiply this side. Let us multiply this side by x, and then multiply this side by x. The x's cancel here, and we're left with 1 is equal to 2x. Now let us divide this side by 2, and then divide that side by 2. 2's cancel, and we get x is equal to a half. So the answer to the question, after all that deliberation, is basically that the x is equal to a half. If you completed all of this, you would have acquired 15 marks. If you followed everything, all the working out and the deliberations, and you can replicate it at an exam, then you would have gotten 15 marks. That is going to be the end of this video. Thank you all for watching, and I hope you've learned something.